Hey, howdy, welcome back. So we're going to continue our discussion on type conversions. Now moving into, if I can find it here, implicit type conversions. So what are implicit type conversions? Implicit type conversions are going to be essentially the automatic conversion of values from one type to another. Such implicit conversions are also known as coercion. So these are going to be things, conversions that we have not explicitly initiated. They'll kind of happen on their own through the execution of our program. So this frequently occurs in mixed mode arithmetic expressions or just mixed mode expressions in general. And in addition to this, in assignment statements and also during the initialization of our variables. When writing mixed mode expressions in C++, the type of conversion that's going to take place is going to be a conversion from the narrowing type to the wider type. Essentially what's going on here is we want to have values of the same type when these expressions are evaluated. If we have mixed types in the expression, one of them needs to be promoted so that the types are matched with one another. So if the two things that we're, say, attempting to add together are compatible, the one of the narrower type will be promoted to that of the wider type. So looking at this, 3.14 plus 8, recall that an integer is going to be narrower than a floating point's double type. Remember, we're dealing with literals here, so in double. What that means is such a double can store a wider range of values, that integer will be promoted to 8.0. So now note at this point, we don't have mixed mode arithmetic happening anymore. We have two values of the same type that can then be added together using the underlying floating point hardware to arrive at the value of 11.14. Notice that the result of this case of adding two doubles together will be a double. So coercion or implicit type conversions, and just to point this out, it's implicit because we never told the compiler at runtime system to do this. The compiler essentially interjected code to make this happen for us. We didn't have to worry about it. So it happens behind the scenes. This can also, I mean, this is convenient, but it can also kind of get you in trouble. For instance, let's consider assignment. And this is where you might run into a couple of issues if you're not aware of this. And I mean, sure, with mixed mode arithmetic too, but I've just seen more problems with the assignment and initialization because it can be a little confusing what's happening. So in an assignment and initialization, a value is coerced to match the type on the left-hand side of the assignment operator. So if we have integer i's equal to the to 9 divided by 5, we're first, assignment is going to happen right to left. So this gets evaluated first. It's double divide by double, so the result will be a double. That result is 1.8. When we attempt to assign a floating point value or initialize an integer with a floating point value, what occurs is going to be truncation. So the decimal point is going to be dropped off that floating point value. There's no rounding, it's truncation. And what we're going to have is 1, so that 1.8 will be converted to the integer value of 1, which will then be used to initialize this integer object I. So the types in this case are compatible. And in order to initialize an integer, we need an integer value. So the compiler will go ahead and generate code to ensure that this happens. Now, let's look at this. The example here, the second one, is not as obvious. And again, always initialize your values. I'm just doing this to show assignment. I didn't have a well-defined value for D and a snippet of two statements. So anyways, so we have D, and we're going to assign to D 9 divided by 5. Notice at this point, we have two integer values, so integer division is going to occur. The result of 1 is going to essentially be what this expression is evaluated to. Now we have 1, and we'd like to go ahead and use 1 to provide a new value to D. Such D is a double, that 1 will be coerced by the compiler to 1.0, and then that 1.0 will be assigned to D. So at this point, D will start out with 1.0.